Hi, my name is Soraya Kaufman. I am doing the assignment and I'm introducing my first technology, which is PhET, P-H-E-T. If you notice that it is founded by the University of Colorado Boulder, this is probably a program that's about 8 to 10 years old. And so they have started developing a lot of different interactive simulations for math and science. And just like this, um, I am a science teacher for secondary education, primarily high school, and I focus more, my specialty is more chemistry, um, more so than the biologies, but I do teach both and I have taught earth space science. I'm not going to try to get hung up on the little things like what the sciences are in here because that's not what this is about. This is dealing with my curriculum, and if you've ever had a science or taught science and you haven't heard about this is a great place. Some people that like me, this is kind of my cornerstone for my lessons. It, like I said again, it's a simulation program and it uses technology or simulations to represent forces, chemistry, and all of that. If you're a teacher, you would register here, just like so, okay? But I'm going to go back. First thing I do want to show is if you look this up, it is PhET, and I would look it up EDU. That's what I tell my students. Sometimes I can't get onto Google Classroom and upload a link, but it's just from there. And it's fat with a P, or fat with pretty hot and tempting. That's what I joke with the kids, but I do have a different group of kids, so I can joke with that. That wouldn't be a joke that you would give probably a first or second grader. So some of these simulations are very, very difficult. Some of them are very basic. And if you notice here that they have all the different types of simulations. Now with biology, this was actually centered around a physical education link. So this is an HTML5. I want to go into that because Google has become so popular now. And Google Chromebooks, that's what our district here at 501 has the initiative of the Chromebooks, and it's a 1-to-1 class ratio. They are not great machines. They're very basic. So a lot of these programs would not support it. But if you have this HTML5 done, they can run the program on their Chromebooks. If they have an Mac, it's a little tricky too. I'm a big Mac person, so I'm going to go back here if I can look at the simulations. I'm here with my parents' house, and if you notice that the Flash and the Java on Mac, I'm having problems running Java. I don't know so much here with the Flash if I can do it. This is a really cool, I can't do it here because they haven't uploaded their, or upgraded their Flash. So I'm going to just stick with the HTML5s because that's what I'm basically running here. There's some that are very difficult. This is actually a very popular one right here. The one thing I wanted to talk about too is that for this program to go into to make it an HTML5, I'm guessing for every single program it cost $100,000 to convert. So our district we got a little grant, we gave some money because we have about 50 to 60 science teachers probably throughout K through 12 that we use it a lot and felt that that was something we wanted to make sure that they had the funding. So this is what it looks like when it's uploading the program. And just to give you guys some things, here they go here. You can start building the park, you can turn it, and you can go slow-mo. And the cool thing about it is they throw so much information in just a little bit of area. We got kinetic, potential, thermal, and total energy, which all those should add up to be 100. So I'm going to go ahead and put her here. And if you notice, this is where you see that the graph is changing. So the kids can clearly see this, that potential and that kinetic, there's something. You may not know what potential or kinetic energy is. And I work at an alternative school, and some of the kids come in with no prior knowledge. They can, even though they may not know what kinetic or potential, they know that there's a change. There's something changing, and they can figure it out. Whenever I do these simulations, I make sure that the kids play with it for a while. I want them to mess around, throw things. Let's make her bigger. Let's make her smaller. Let them get used to the program before I throw in the assignment. And I'll show you some tools here just for the assignments. I'm going to go to one of my favorite ones. Is, if I can find it, I'm going to go to the HTML ones because I just saw that this was a new one, which makes me very, very happy. This is a pretty cool one before I go here. This is John Travoltage, and this is very, very silly. So you move his hand and you shake his leg, and you move his hand and it, ow. And it's just, this is just pure silliness. So that one is just for fun. Where was the one that I have is my favorite? And I saw it. I'm going to pause for a second so I can pull it up. This is my favorite one because it conveys, as the Energy Skate Park one, it shows a lot of different stuff in just this little thing. So if you notice here, here's an atom. We can't display this. This is a good presentation. This is something that, yeah, they can maybe have a kinesthetic thing where we have marbles and then we weigh them. But this is just done so easily. They can interpret that this is a scale, this is a type of measurement, and this is an isotope. I like to throw this on here to have the kids see this, and they notice, oh, something's shaking. It's unstable. I do this before I teach isotopes. I do this before I teach ions. I think it's important for the kids to understand that, see the visualization, and then I get to teach it. I don't think it's important. I think if you taught isotopes and what it is before you showed this, you lose that ambience. You lose that, oh, why is it shaking? I wonder why, huh? And then I go to mixtures here, and then they get to play. I've had kids make dinosaurs and Yoshi, but I think it's important for the kids to do that first and then have the lesson, because then they get familiar with the program. And then they see something like this and they're like, well, what does this mean? And then I get to introduce, well, what is hydrogen closer to? 1 or 2? And so then they get to see that natural mixture of, oh, there's more hydrogen 1s than hydrogen 2s. And then I throw in another lab. So one thing I wanted to, I've been talking about letting them play, but here's kind of the creme de la creme of all this, is that they do have worksheets for you. And so you can go on to this, and I'm hoping that I might try to have, I'm going to pause one more time and mess it up. So I had to log in. There's just, and this is my school email, and I just have like 3 emails. So just want to make sure which one it was. So they have PDFs and they have Windows. So I have them, and you can either write it out for the kids, or you can have them do it on the computer, and I'll have this loaded up. So if you notice here, and it's got all of them there. you can go onto Word and you can make it your own. So they're very fortunate. They have that. The kids look at it and then they go through the steps. So, like I said, I had the students go and look at that and it says, well, what number determines the mass number? So they have to go over here and look. Sometimes I introduce the vocabulary and sometimes I don't. So if you notice here, mass number, that's maybe something new to them. But sometimes I hang them out to dry. I tell them that they're used to it. So they look here and they have to discover, oh, where's the mass number? And then I put that here, oh, this thing called neutrons. And then why is it? They may have to take a guess. And like I said, I have a very small class, so I can correct them if they're going wrong. It's different when you have a bigger class. You might want to put these in teams, have somebody write, switch. And then they go through that. Then they take a graph, and most of these do have graphing, and then they have to interpret the graph. And then there's an exercise at the end. So I'm probably going to wrap this up with PhET, but once again, this is just a really cool website. I recommend playing with some of these. Some of these I do not use. I don't have to use them because some of them get very technical, some of them don't. But here's a mathematics one, a trig tour. And then they can see, so there is math, but it's very limited. It's like the biology where it pertains to the physical sciences, which I do think is the cornerstone of science, not so much the physics or the biology. So here, like I said, here's a simulation of the math. Really excited about that because I'm going to teach math this summer or this next semester. And the kids can see that it's triangles, it pertains to circles. And then you've got your quadrants. I'm sorry if I'm kind of going over people's heads, but I recommend it. Go look at it and go look at those teacher worksheets. They are usually really good. And then you can go, if the kids struggle for a bit, work it through with them, and then it becomes awesome. And then you would see the kids, well, I don't know how to do this. And then before I can get there, the kids jump in and actually help them out. So, alrighty, I will talk to you later. Thank you. Bye-bye.